Hey guys, what's up and welcome back to another video of Geeked on Science. So as you can see today we're going to be learning more about the periodic table. This is a continuation of our other video that we already posted about the alkali metals. I'll put the link in the description so you can go learn more about those elements before these, after watching this video. Today, as you can see, we're going to be learning about the noble gases, which are helium, neon, argon, krypton, xenon, radon, and oganesson. So, without further ado, let's get right on into it. So first of all, before we do anything, we have to understand where and why the location of the elements matters. First of all, the noble gases are nonmetals, which are basically, as they state, not metals, and they're located in group 0 in the periodic table. Group 0's more common name is group 18 because there are 18 groups in the periodic table. However, I like to say group 0 because of their elemental reactivity, none. But before we do anything, let's understand what groups are. Groups are the way in which you address the area of a specific element. I made a more specific video on groups and periods. You can go watch that one after this one if you want to learn about more in depth. I'll put the link in the description. Now that we understand the location of these nonmetals, let's understand some of their physical properties. Since noble gases are gases, as they say in the name, and they have no reactivity, and they only have one physical property, which is boiling points. The noble gases have all low boiling points, and unlike our last video in alkali metals, in which the boiling point decreases as you go down, here the boiling point increases as you go down the group. So as you can see, meaning that helium actually has the lowest boiling point, and oganesson has the highest boiling point, and that is of the noble gases only. Now, from helium downwards, the atoms become larger, which means that more energy, or ionization energy, is required to overcome these forces. Now, I explained ionization energy in the alkali video, but ionization energy is basically the amount of energy required to rip apart the attraction and intermolecular forces between atomic substances. You can go learn more about that in the alkali metal. As I said, the link will be in the description. And now that we've understood the physical properties, we actually also have to understand the chemical properties. Now, just like the physical properties, noble gases only have one chemical property, reactivity. Now, reactivity here means that, unlike a lot of elements, noble gases are extremely unreactive. So, scientists actually call these chemicals inert elements. This is because they don't take part in chemical reactions, and even if they do, it's extremely rare. So, this is because all noble gas atoms, like helium, neon, and argon, for example, have a full outer shell of electrons. This means that their 3 valence shells, 3 to 4 valence shells, are completely filled, meaning that they would not need to lose or gain an electron because they already have a full outer shell. In fact, elements only react because they want to achieve a full outer shell, and since these elements already have a full outer shell, they do not need to react. Hence, they are extremely unreactive. So now that we've understood the physical and chemical properties, let's understand some of the uses of our first 3 noble gases: helium, neon, and argon. Now, if you didn't know, helium has an extremely low boiling point, and that can make it very useful. In fact, medical imaging and research can actually use helium to cool superconducting magnets. So like X-ray images use helium to cool superconducting magnets in them. And helium's also used in the leak testing technology industry, but that's less commonly known. The most common use of helium is gas in balloons. which is why most balloons are actually called helium balloons. Now you can use other gases, but they won't float as well. Hence, helium is actually one of the most commonly used noble gases. Now let's learn about neon. Neon, the famous pizza street sign, cityscapes, popular site, and used in advertising. Just like helium, its extremely low boiling point makes it famous in neon signs, and some other uses, which are less known, is the cryogenic refrigeration, which stores things in extremely low temperatures by freezing them. But, as I said, the most common use in cityscapes and advertising are neon signs. Now, let's learn about argon. Argon is actually used in electric lights, meaning like your car lights or the lights in your house. And since it's a noble gas, its unreactiveness is actually what makes it so much safer than most other gases. Now, another less common use is welding to prevent oxidation and contamination during the welding process. Now, oxidation just means the eating away of metal due to oxygen, and I'm sure all of you already know what contamination means. Another less commonly known use is argon is used in lasers, which actually have many medical and scientific applications. So argon is one of the more useful noble gases. Now, let's learn where the noble gases come from. Now, neon, argon, krypton, and xenon are found in the air. However, you might be like, what about radon and oganesson? Those are radioactive elements produced from the decay of the heavier elements and the other side of the periodic table. Now, how do we get the elements in the air? How do we know they exist? Well, they can be obtained by liquefying the air, and that's carried out in a process called fractional distillation, which basically takes the air and cools it down to such a temperature that it becomes water. Now that we've learned everything about the noble gases, I can wrap up this video. Thank you so much for watching, guys, until here, and if you made it, I only have one request. If you enjoy these videos and would like to support me and other people like me, please do like, share, and subscribe, and I'll see you in the next one. Thank you so much for watching once again.